All right, let's jump right in. If your web application is built on React or Next.js, you're going to want to listen to this. We're about to break down a really critical vulnerability called React2Shell, and honestly, it needs your immediate attention. So let's start with a number that tells you everything you need to know: 10.0. On the Common Vulnerability Scoring System, or CVSS, that is a perfect score. You can't get any higher. It means this thing is as dangerous and as easy to exploit as a vulnerability can possibly be. It's the absolute worst-case scenario.
And this is not some theoretical what-if kind of problem. The moment this vulnerability became public, the race was on. Amazon's own security teams confirmed that within hours, literally hours, attackers were already out there, actively trying to exploit this, scanning the internet for anyone who hadn't patched yet.
So let's really dig into why this vulnerability, which is tracked as CVE-2025-55182, almost immediately landed on CISA's Must Patch Now list and sent some serious shockwaves through the entire security community. Okay, the technical term for this is pre-authentication remote code execution. And yeah, it is just as bad as it sounds. Remote code execution means an attacker can run any command they want on your server. And the pre-authentication part, that means they don't need a username, they don't need a password, they need nothing. They can hit any vulnerable server from anywhere on the internet, no special access required. And the scale of this problem is just staggering. Research from the security firm Wiz found that a massive 39%, nearly 4 out of every 10 of all the cloud environments they looked at had vulnerable versions of React or Next.js running. Just think about that for a second. That is a huge chunk of the modern web. Okay, so how does an attacker actually manage to do this? Let's get into the technical guts of the vulnerability. Now, it sounds complicated, but the central idea is actually something we can all wrap our heads around. At its heart, this whole thing boils down to a classic flaw called unsafe deserialization. Now, the best way to think about it is like this. Imagine your server gets a package of data, and it comes with an instruction manual on how to unpack it. The server expects a safe manual, but an attacker sends a package with a malicious manual, one that basically says, okay, unpack all this stuff, and oh, by the way, also run this secret command that gives me total control. And because the server doesn't properly check the instructions, it just follows them blindly. Game over. All right, this slide right here is critical. If you need to, just pause and take a look. If your production environment is running any of these versions of React or Next.js, you are vulnerable. It is that simple. This is your immediate to-do list. And here's the really scary part. You don't need some weird, custom, non-standard setup to be at risk. The security researchers over at Wiz confirmed that a default, just straight out-of-the-box Next.js application is exploitable. That means your standard, everyday deployments are immediately in the line of fire. Now let's shift our focus from the how to the who. The second this vulnerability became public knowledge, a frantic race started between the defenders, like you, trying to patch, and the attackers trying to cash in. This timeline just goes to show you how ridiculously fast things move in cybersecurity. On November 29th, this flaw is a secret between researchers and vendors. By December 3rd, the whole world knows. And within hours, not days, hours, it's being actively used in attacks. Just 2 days later, it's on the US government's official list of vulnerabilities that federal agencies are required to patch. That's lightning speed. And we are not talking about some random hackers in their basements here. AWS Threat Intelligence quickly figured out that sophisticated, state-sponsored groups, we're talking actors like Earth Lamia and Jackpot Panda, were among the very first to start launching these attacks. This shows a really systematic, professional effort to weaponize these things as soon as they drop. What's really fascinating here is the different styles of attack. On one hand, you had the less sophisticated actors just grabbing public proof of concept code and basically spraying it across the internet, just hoping something would stick. But on the other hand, AWS watched one group methodically spend almost an hour sending over 100 requests just to debug and perfect their attack against a single live target. That is a completely different level of dedication and persistence. So, what actually happens when an attacker gets in? The initial breach? Well, that's just the beginning. Let's take a look at what they do next to really capitalize on that access they just got. The researchers at Wiz saw a very clear 3-step attack pattern. Step 1, they use the exploit to get a shell, which is basically just a command prompt on the victim's server. Step 2,
They immediately start hunting for treasure, API keys, cloud credentials, anything they can find to move deeper into your network. And step 3, they install their own software, like malware for long-term access or crypto miners to make a quick buck off your hardware. And you can see their specific goals right here. They're trying to steal AWS credentials so they can pivot from your web server into your entire cloud environment. They're grabbing sensitive files with user information, and very, very commonly, they're installing crypto miners like XMRI to hijack your server's processing power to mine cryptocurrency for themselves, leaving you stuck with the bill.
Okay, we've gone over the threat, how it works, and what happens after a breach. Now let's get to the most important part, what you need to be doing right now to protect yourself. First, a quick but really critical point. A lot of cloud providers like AWS and Google Cloud, they pushed out rules for their web application firewalls, or WAFs. And these are great. You should absolutely use them. But think of them as a temporary shield. They can help block known attack patterns, but they do not fix the root vulnerability in your code. They are not a substitute for patching. I repeat, not a substitute. So here is your 3-step action plan. Number 1, and this is the absolute top priority. Update your dependencies. Patching your software is the only real permanent fix. Number 2, go ahead and deploy those WAF roles. They're an excellent extra layer of defense while you're getting things patched. And number 3, you need to start digging through your logs, hunting for any signs that you might have already been compromised. And here are the safe versions you need to upgrade to. This is your target. For React, you're looking for versions like 19.2.1. For Next.js, you want to be on at least 15.05 or higher. And hey, there is some good news here for anyone still on Next.js 14. The stable versions were not affected by this. While you're in the process of patching, you need to be on the lookout for these specific breadcrumbs in your server logs. Are you seeing any weird post requests with headers like these? Are there any unexpected processes being launched by your web server? Are you seeing simple reconnaissance commands like "Who am I?" or "ID" being run? These are all classic telltale signs that an attacker has been probing your system. Or worse, that they're already inside. And that really brings us to the bottom line. This is not a drill. Automated scanners and highly sophisticated attack groups are actively, right now, looking for vulnerable servers. So the only question that really matters is the one right here on the screen. Have you patched yet?